Okay, I'm playing around at the moment with a non-inductive bifilar coil. In fact, I've got two bifilar coils wound on this tube side by side. There's about 7 turns on each. They're terminated at the end there, nothing connected to them, and they run in parallel down a couple of dies, flyback dies across them just there. I'm using a bulb in series for the supply to stop me drawing too much current. Difficult to see with the focus there. The bulb is alight just slightly. I'm pulsing at 50 kilohertz with a 35 nanosecond pulse width on each channel, each FET. I'm only really driving one of the coils. The other one I'm just monitoring with the scope as well, just really monitoring that just to keep an eye on it. I've got an analog current meter there which is moving around. Some digital supply is alternating between, well, up to about 45 milliamps. I'm running at 61 volts. It's a 12 volt 5 watt bulb I'm using there. Now I'm getting bursts, random bursts. The scope settings, the time base is on 4 microseconds. The green channel is actually the driven non-inductive coil, and that's on 50 volts per division. The yellow channel is just the monitoring channel. It's not actually connected, but of course it's running next to the driven coil. That's 10 volts per division. It's a shame you can't see the bulb. It's quite interesting. Although it may look like it's on all the time, it's actually pulsating. I can show you the pulsating current maybe a bit better there on the meter. You can see the meter moving up down. If I start moving the coil, if I face it, if I move it around, it varies. That's about 45 degrees. There, see the bulb pulsing. You know, if I lay the coil down, it's still pulsing, but if I move it around different amounts, it alters. I don't know what I'm actually seeing here really. Quite an interesting effect. I think this is probably related to the explosion in the wire experiment I was doing, but because I'm using a non-inductive coil, it doesn't seem to be affecting my computer so much. The processor's not crashing out. So it's enabled me to study it a bit better, and also the bulb is stopping real high current surges as well. So quite interesting really. If I call up the FFT, the spectrum, zoom out on the time base. Pulse is totally random when it occurs. That's the weirdest thing about this. You know, at the end of the day, all I'm doing is putting 2 very narrow pulses into a length of wire, yet the current is jumping all over the place. We're getting bursts and noise up to about 30 megahertz there. The vertical range is 5 volts per division, and the time base on the FFT is about 6.25 megahertz per division. Quite interesting effect really. I'll go back to